Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Differentiate the following: y equals 2x minus 5 the whole power 4 divided by 8x square minus 5 the whole power 3, right? So we have a function of the type u by v, right? So we know which rule we will have to apply, to arrive at the derivative of y, right? So I will have to apply the quotient rule of differentiation, right? So before we write down the quotient rule of differentiation in these problems, right, what we observe is that my numerator is not a very simple expression which I can immediately figure out the derivative, right? We earlier saw problems in quotient rule and differentiation where your u and v, which is your numerator and denominator, you are quite familiar with the derivative of u and v. Means it could be directly substituted, right? But in this particular problem, we see that my numerator is 2x minus 5 the whole power 4, and my denominator is 8x square minus 5 the whole power 3. So how do I go about solving these problems, right? So I still apply the quotient rule, but before I apply the quotient rule, I solve for the derivative of the numerator and the denominator using the chain rule before I jump to the quotient rule, right? So now that we have solved many problems in using the chain rule, and if you've not taken a look at it, please take a look at my earlier videos. I'm going to, jump straight to making the substitution for the numerator and then for the denominator before we actually come to the quotient rule and solve this particular problem, right? Let's write down what is our u, v, and f of x, right? So I'm, I'm going to write this down for you. What is my f of x? My f of x is nothing but my y. So I put this up out here, and my u, which is my numerator, because I'm going to apply quotient rule to solve this particular problem, is nothing but 2x minus 5 the whole power 4. My denominator, which is v, which is 8x square minus 5 whole cube, right? And then I have my f dashed, right? My f dashed is nothing but vu dash minus uv dash divided by v square. Okay, so we are going to use the chain rule to solve for u dashed and v dashed before we come to the quotient rule. So I'm going to pick up u first, right? My u equal to 2x minus 5 the whole power 4, right? So let's make the appropriate substitution. So if I make the substitution t equals 2x minus 5, right, my u gets reduced to a very basic t to the power 4, right? And why is that? Because when I make the substitution t equals 2x minus 5, my u can be expressed in terms of t. It is nothing but u equals t to the power 4, whose derivative, which we are quite familiar with from first principles. So I make this substitution. I go to the next step. I express my u. What is my u? My u becomes t to the power 4, right? So let's write that down, t to the power 4, right? And what is my du by dt now? My du by dt is nothing but of t to the power 4. I will have to apply the formula d by dx of x to the power n is equals to n into x to the power n minus 1. So when I apply the formula, my n is equal to 4 here, and my t to the power 4 becomes t cube, right? So let's do that. Right, so 4t cube is what is my du by dt. And then I have my 2x minus 5. I'll go up and then calculate my du by dx, sorry, dt by dx, right? So my dt by dx is nothing but d by dx of 2x minus 5, which is d by dx of 2x, which is 2, and d by dx of minus 5 becomes 0. So my answer for dt by dx is nothing but it is 2, right? So I have my dt by dx. Let me highlight it using a color. Let me highlight it using yellow. I have my du by dt, which is Let me highlight it using green, which is nothing but 4 times t cube. And then I will have to figure out what is my du by dx. So let's go back to u and let's figure out what is our du by dx. So what is my du by dx? My du by dx is nothing but du by dt into dt by dx, right? That's nothing but my du by dx is my du by dt, du by dt into dt by dx, right? So my du by dt is nothing but the green expression which I've highlighted below. So let me pick that up. And then my dt by dx is nothing but the yellow expression which we just worked out. And let me pick that up as well. I'm just highlighting the colors. So my du by dt is nothing but 4t cube. My dt by dx is nothing but 2. So my final answer is a product of these two. Not my final answer. My answer for u dashed is nothing but 8t cube, right? So what is my 8t cube? Let me use turquoise. My 8t cube, I'll have to go back and express it in terms of x, right? So it is nothing but 8 times 2x minus 5 the whole power 3, right? I'm going back and replacing t with the original substitution that I made. So there I have my du by dx, right? So it is 8 times 2x minus 5 the whole power 3, right? And then now that I have my u dashed, right? Now I'll have to go about and calculate what is my v dashed, right? So let's move down and let's calculate our v dashed, right? My v equals 8x square minus 5 the whole cube, right? So let me do that. And so what is my dv by dx? My dv by dx is nothing but v dashed, right? So I'm going to make the substitution which will simplify v and bring it to a format whose derivative we know by first principles, right? And we have 8x square minus 5, and the best substitution and probably the only substitution that's possible out here is 8x square minus 5 equals t. So let's do that. Remember folks, we're solving for u and v independently, so I'm still using the same uh, substitution t. So do not get confused between the t I use to solve for v and the t which I'm using to solve for u, right? So let's make the substitution t equals x square 8x square minus 5, and let's do my dt by dx, right? So what is my dt by dx? My dt by dx is nothing but an application of my sum rule. So d by dx of 8x square is nothing but 8 into 2 into x, which is 16x, right? Again, an application of x to the power n, right? A derivative of x to the power n. And then I have my minus 5, which is nothing but dt by dx of minus 5 is 0 because it's independent of x. So I have my answer for dt by dx, which I will mark it in yellow. And then I need to figure out what is my dv by dt, right? So I go to the next step. I make a substitution for uh, 8x square minus 5 in terms of t. And then what is that? My v becomes equals t cube, right? So let's write that out. V becomes equals t cube. And now that we've successfully reduced my v in terms of t, what is my dv by dt? My dv by dt is nothing but, again, an application of x to the power n. The derivative of x to the power n equals n into x to the power n minus 1. So dv by dt will be nothing but 3t square. So I have my dv by dt. Let me highlight it in green. And then I have my dt by dx, which is 16x. So I've been asked to find, or I will have to find dv by dx before I jump to my quotient rule, right? So what is my dv by dx, right? So my dv by dx is nothing but, from chain rule, it is nothing but dv by dt into dt by dx, right? So my dv by dt is nothing but 3t square. So I'm going to write that out. And then I have my 16x, right? 3t square dot 16x, right? What is that? So I have an expression in terms of t and x. So I go back and do the substitution to eliminate the term from t. So I put back my t in terms of x. So I have 3 times 16 as 48. My x remains as it is. My t square becomes 8x square minus 5 the whole square. Right, so there I have my dv by dx. So what is my dv by dx is nothing but the v dashed which I have in my quotient rule. So let me, I have my dv by dx, I have my du by dx, right? So let's write that above. I go back to my quotient rule. I'm going to write what is my u dashed and v dashed, right? So my u dashed is nothing but du by dx, right? My u dashed is du by dx, which is 8 times 2x minus 5 the whole cube, right? And then what is my v dash? So let's write that down as well. My v dash is I go to my earlier step. My v dash is nothing but 48x into 8x square minus, right? So this is what I have. So I have my u dashed, I have my v dashed, and then we have our u and v, and our final answer is nothing but a substitution of u, v, u dashed, and v dashed into the expression f dashed, which is what I'm going to do in my subsequent steps. So let me highlight it by a turquoise, and I'm going to pull this out and bring it to the next step. And all that I'm going to do is to do a substitution of these expressions from my u's and v's and u dashed and v dashed, right? So what is my v square? My v square is nothing but 8x square minus 5 the whole cube the whole square. And what is that? 8x square minus 5 the whole power 6 is what you will get, right? So this is my v square. And what is my v? My v is nothing but 8x square minus 5 the whole cube, right? So I write my v as it is, and then I have my u dashed, right? What is my u dashed? My u dashed is 8 times 2x minus 5 the whole cube, right? So I pull that out. I write it as it is here in the numerator. So that is my vu dashed, folks. And then I want you to observe these steps very closely. Next, we are coming to our uv dashed. So what is my u of uv dashed? It is nothing but 2x minus 5 the whole power 4, right? So I have my 2x minus 5 the whole power 4, which is my u. I just paste it as it is. And then I have my v dashed, which is nothing but 48x 8x square minus 5 the whole square, right? So I pull that out as well. So this is what I have. So there I have my final expression, which again definitely looks like, it calls for some further simplification to be done. So I'm going to repeat this step again. My v square is nothing but 8x square minus 5 the whole cube times the whole square, which makes it 8x square minus 5 the whole power 6. And then my vu dashed is nothing but my v into u dash. So what is my v? 8x square minus 5 the whole cube. And what is my u dashed is that I've worked out in my previous step into 8 times 2x minus 5 the whole cube. And then I have my minus of uv dashed. My u is nothing but 2x minus 5 the whole power 4, which is the numerator. And then my v dashed is what I worked out, using the chain rule, which is nothing but 48 times x, 8x squared minus 5 the whole square, right? Now, before we go to the next step, I want you to observe this very closely and see what are those common factors that we have, right? I see that I have an 8x squared minus 5 the whole power 6 in the denominator, and I still have an 8x squared minus 5 expression in the numerator, right? So I can pull out an 8x squared minus 5. Uh, what is that I can pull out? I have an 8x squared minus 5 whole cube in the first part of the numerator, and then I have an 8x squared minus 5 the whole square in the second part of the numerator, right? So I'm referring to this term. Let me highlight it in, say, what is the color I can use? 8x squared minus 5, and then I will also highlight this part, right? So I can pull out 8x squared minus 5 the whole square, right? So let me do that in the next step. So my f dashed is equal to 8x squared minus 5 the whole square. So let me pull out 8x squared minus 5 the whole square. I'm going to keep it as it is for the minute. And then I'm going to pull out my favorite open bracket, because I'm going to put the remaining expressions inside my bracket. So I have pulled out 8x squared minus 5 the whole square. So I'm going to write down what is the first part of my numerator, right? Pull out this, and then I still have my 8x 8x square minus 5, right? Because I've pulled out 8x square minus 5 the whole square, but my first part of the numerator has 8x square minus 5 the whole cube. So then I still have 1 8x square minus 5 in the first part of the numerator, which I write it as it is. And then I come to the second part of the numerator, which is my 2x minus 5 the whole power 4, which I write it as it is. And then I have already pulled out my 8x square minus 5 the whole square, so I do not have to do anything. So I have my 48x as it is. And then remember, folks, I still have my 8x square minus 5 the whole power 6 in the denominator, which I'm going to just write it as it is before I make the cancellation of 8x square minus 5 the whole square with the term in the denominator, right? So I can pull out my pencil now. We know which terms we're going to cancel out. We're not going to cancel out the entire 8x square minus 5. So I'm going to cancel out my 8x square minus 5 the whole square with the 8x square minus 5 the whole power 6 here. So then I have an 8x square minus 5 the whole power 4 in the bottom. So let me write it. So let's write it out. So this is my step 1. And then before I write my numerator, I do notice that my first part of the numerator has got a 2x minus 5 the whole cube, right? So let's highlight it again using a different color. This time I'm going to use green, folks. So I have a 2x square minus 5 the whole cube here. And then I have a 2x minus 5 the whole power 4 in the second part of the numerator as well, right? So I know what is it that I will have to pull out here, right? Again, I notice that I have a common factor. What is my common factor? My common factor is 2x minus 5 the whole cube, right? So I pull out that. So let me pull out 2x minus 5 the whole cube, right? And then I'll go ahead, open my flower bracket to represent the remaining terms inside the bracket, right? So I pulled out my 2x minus 5 the whole cube. So I still have my 8. Remember, folks, we are on the first part of the numerator. And then I still have my 8x square minus 5, which I will copy as it is. So I have my 8 into 8x square minus 5. So let's copy it as it is. And then I have a minus sign. And remember, folks, we still have our 48x, and then we have our 2x minus 5 still, right? Because we pulled out 2x minus 5, the whole cube, and we still have 1 2x minus 5 in the second part of the numerator, right? So I'm going to move to the next step where we will conclude what is our answer. I don't think we can do any further simplification. So there I have pulled out, what we extracted out in our previous step. 2x minus 5 the whole cube divided by 8x square minus 5 the whole power 4. I don't think we can do any further, uh, you know, cancellations in this. And then I represent my other expression, which looks like a quadratic expression, right? So let's see what do we get. We have 8 into 8x square minus 5, which is nothing but my 64x square minus 40. I hope you folks are following me. Minus 40. And then I have a minus 48x into 2x, which is minus 96x square, right? And then I have a plus 240x, right? That's what I have inside my expression. So let me write it out again. I think I can do a simplification with respect to x square, right? What is that simplification? So my 64x square minus 96x square is nothing but minus of 32x square, right? So I write minus of 32x square, and then I have a plus 240x, right? And then I have a minus 40, right? Looks like we have a quadratic expression, which is minus 32x square plus 240x minus 40, right? Is it possible to do any further simplification? The answer is yes, because I think 32, 240, and 40 have 8 as a common factor, right? So I can pull out my 8 when I represent my final answer. So my final answer is 8 times 2x minus 5 the whole cube, right? Divided by 8x square minus 5 the whole power 4. I pulled out my 8, folks, remember that. And then post pulling out my 8, what is my final answer? My final answer here is I have pulled out my 8, so my minus 32x square becomes minus of 4x square. And then my plus 240x becomes plus 240 divided by 8, which is plus 30x, right? Plus 30x. And then my 40 becomes 40 divided by 8, which is a minus 5, right? So there I have pulled out 8 and represented the quadratic equation as minus 4x squared plus 30x minus 5, right? So there I have the final answer. I don't think I can do any simplification further. Let me represent it using a different color. What is my final answer? Highlighted in pink, folks. I'm sorry because I'm using too many colors. So the final answer to this problem is 8 times 2x minus 5 the whole cube into minus 4x square plus 30x minus 5 the whole divided by 8x square minus 5 the whole power 4. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.